My name's Peter Cooper and welcome to my shop. We're going to cut some metal today. Keep watching.
NGG16. Here's the guy, drawn full size from the blueprints from the Museum of Science and Industry, MOSI, in Manchester. And there's some quite interesting parts. If we look at, for example, this one, the motion bracket, that's going to be an interesting thing to make. We'll come back to that one though. We'll start with something a bit simpler. The front buffer, this guy here. Okay, it's what we saw last time, full size. It's 83.5 inches by 28 5/8. Big chunk of metal. But when we scale it, it becomes a bit smaller. Sheet metal, 3mm think, which will come out at 17.5 inches by 5.96. 17.5 is a good number. It just fits inside the work envelope of a toolmac, so I can do it all in one pass, I hope, if I set the thing up right. So it's 3mm steel, cut out a big chunk. We got these hole profiles, a couple of little square holes here, they could be interesting, and 3 sizes of hole. Small ones down here, some larger ones here on both sides, and all the rest of the holes, those are the same size. So we've got a lot of holes to drill, and we've got the profile to make. Let's see what we can do. Making a part is you've got to bring into the CAM program, create toolpaths. I know you could do by hand, but I'm using SprutCam. This is SprutCam 8, latest version, and in fact I had it just hot off the press, just when Eric and Tormac released it. The problem is it was crashing a bit and a bit buggy, so I've only just installed the very latest release, which is... no, not there, let's try another one. That one there. SprutCam 64-bit build 0.3 revision 62410. I think Eric released it a couple of weeks ago. Just on that, if you see me looking over to my right hand side here, your left, I'm actually working with 2 screens. I've got my laptop main screen, and I've got another screen at the side there where I can drag and drop between the different screens, and it gives me a lot of real estate to see what's going on. So it's a very simple part. I'm not going to go through the making the individual toolpaths. As I say, it is so simple. There's tutorials from Eric and sprut.co.uk, which I find very useful, been through them an awful lot. Let's just see what it does. First one is a spot drilling operation to spot the holes. Then we drill the small holes and take out a bit of these square holes, just to make it easier for the small mill to go around them. Then all the what were 3/4 inch holes in full size, and then those bigger holes around the side. We then go for the contouring of the inner pockets. Just for interest, what I'm doing here is going down, it's 3mm thick plate, 3mm thick plate, say that again properly. And I'm going down in three steps. We shall go all the way through the mill. I got the feeds and speeds, I'll show you that in a moment, from GWhiz. I'm actually leaving on the stock 0.05 thou, sorry, 0.05 inches, 50 thou, for cleaning pass operation. So the 3 passes go down in steps, and then the next operation is exactly the same but takes off that 0.05 inch remaining stock in a single full depth pass. Then we go around the outside, take 2 steps down, and then the 3rd step I'm actually adding some fixtures, so they'll step over it and leave tabs or bridges 1, 2, 3, 4, 5, 6 to see if it goes. And the last operation, contours, everything else, again I'm leaving 0.05 in the first pass, in the 3 steps down, and the last pass is a full depth pass to give a nice good finish. And then I swapped a little 1/18 mil just to take out the corners here that the 1/4 inch wrong 1/2 inch mill couldn't get into. And let's see it in the simulation. Reset it. Yeah, there you are. I can see the fixtures. The fixtures only appear in the not the first operation, they only appear later on. It's having a think. I don't like SprutCam, and it's I'm a computer expert, that's my day job, and I find it buggy and awkward and obscure, but it seems to be comprehensive. I don't think it's anything much better than all the other CAM programs. I say because it seems to have all the features that I would ever want, I might as well stick with climbing the learning curve. It's been steep, but not as steep as SolidWorks say. One of the problems that I had, not being a machinist, a lot of the options meant absolutely nothing to me. I mean, what are these options? I don't know what they do. Which ones do you choose? So I've taken a lot of the defaults, taken the feeds and speeds from GWiz, and let's see what's going to happen when it gets there. Well, that wasn't very impressive, was it? Didn't do anything. There we go. I'll speed it up so it goes quite quickly. It's no representation of the actual machining time. One of the tips that I got off, I think it was sprut.co.uk, is that it gives you an indication. If you hover over that, each of the operations, it actually gives you the machining time. So it reckons this is going to be 45 seconds. I don't believe that. It took much longer. Let's try another one. Hover over the second one. Oh yes, I know what it was. Hover and maybe move a bit. There we go, 2 minutes. The one that takes quite a while is the spot drilling, because there's a lot of holes to spot drill. And highlight it. Highlight it. Did I say it was quirky? It's going to take 5 minutes. 5.5 minutes. I'm still not sure I've got it right. That says 5.5 minutes. This contouring pass says something. You have to hover and move a little bit. There we go. 5.22 minutes. Maybe I have to stop it. Let's just stop it a moment. And hover over it. 2:37. Ah, that sounds better. 5:25. Little wee holes, small ones at the front. 45 seconds. So you can get some indication there. It is only an indication, and there's somewhere, see the tutorial on sprut.co.uk on some tuning to put a ratio in to fit your actual machine. Let us resume. So I've drilled out the square holes here. I've drilled them out with the small drill to take us on the material, so the 1/8 inch cutter is not going the full width of the cutter. Oh, speed it up because you've seen most of it anyway. There we go. Whizzing round. And off we go. 3 passes to get through it. Let's just slow it down a bit. And it's leaving 0.05 inches of stock as a single pass to clear up. Steps down in 3 and then in a single pass to clear up. Let's speed up again. Whiz, 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 whiz. And then slow it down, and you'll see it's taking out a full depth pass the last 0.05 inches. Okay, the outside profile is going to be interesting because we've got to hold the material, and what I'm doing again is taking it down in 3 passes all the way around the outside. 1/2 inch end mill, flat nose, centre cutting. It's high speed steel, tin coated, I think. There's the second step. And you must remember I'm a total newbie at this. I got no idea what I'm doing, so not 100% sure how it'll turn out and whether it'll hold okay. In fact, because I've already done it, I know it doesn't. And for the third pass, I've added 3 fixtures, so it skips over that, leaving a very small bridge or tab to hold in location. I ran the inside holes first rather than the profile because it would be stronger. The profile tends to bounce up and down. We'll see that too, because there are a couple of faults in the thing. And the last one I swapped to... oh, there I go again. 3 passes going down at 1.5, I think, sorry, 0.15, and then a finishing pass at full depth. Then we swap to a 1/8 end mill. Let me just slow that down, you can see it. Run to here. So I've just simulated the whole machining process up until this last operation. Slow him down and zoom in maybe. He's having a think. You can see the rest material there that's left by the 1/2 inch mill where it couldn't get into the corners. Going a bit slow, I think. Let's speed you up a bit. There we go. Oh, for some reason he wanted to do that. I've got no idea why I wanted to do that. I chose the rest machining operation. And because it's only a little wee tiny mill milling steel, it goes down in a number of passes. Just to clean out the corner. On the finished job I can see a little line just there where it joins, where the material's moved a bit. I think on hindsight I should have used the 1/8 mill to do the remaining stock, clear the stock all the way around, as well as get into the corners. It's not very noticeable, it'll emery cloth out. But maybe that's what I'll do for the second one, because on the NGG16 there's at least 2 of everything. One for the front engine, one for the hind engine.
So, one of the many learning curves I've got to climb is work holding. Here's a stock, big piece of stuff. Here's my famous Tozer tooling plate. Less said about that the better. And we've got the standoffs, which are screwed into the holes. There's no particular accuracy here, holding it left and right, up and down. It becomes solid. So I reckon for this, I'm going to clamp it with standard clamps. Going around the edge. I have no idea if there'll be any problems with this. As I said, it's all part of the learning curve. So the stops. And that should be it. I've got to be a bit close, a bit tight, because it's over 17 inches of milling around the edge profile. So I can't afford to start too far in. This is the 0 up here. Otherwise I'll run into the end stop on this side. So I start off with the home position, and I'll just move it about 1/4 inch. And that should, I hope, take me all the way around without crashing the end stop on this side.